Today we are going to talk about three types of sorts. For insertion sort, selection sort is very easy. It's like for the children, and merge sort is more serious and a little bit harder. So let's start from revision. Do you remember a bubble sort?
Yes.
Everyone? Like, very simple concept. When I was in university, I thought I invented a bubble sort because it's the first algorithm that comes to your mind when you're trying to sort something. So let's talk about insertion sort. It's pretty similar, and now we're going to talk about this. So imagine we have some amount of elements, unsorted elements in our array. So how insertion sort works? We check in two elements, for example, 5 and 2. And like in bubble sort, we check in if the second element is like less than first one, we we are swapping them, right? So yeah. Now we swap in two elements, and for example, here we have null, 0, not null. So what happening now? Now we check in this element and this element, and we see that this element is less, not less. How do I say? Like, okay, this element less than this one, and in bubble sort we would stop on this on this operation and just swap them. But in insertion sort, we will continue checking other elements. So we compare to those two elements, and we see that our current element is less than previous. Okay, we moving on. Now we comparing this element with the previous one, and we see that like one more time, our element is less than previous element. And if it's the end, if it's the start of our list, we are doing swap. And now we're doing not the swap, we're doing like insertion of this element. So we're doing such operation. Is this clear? Okay. Next. For example, we are moving next, and our current element is 1 now. We check those, like this element less than this. We're moving on. We're checking those two elements. This is less than that one. We're checking those two elements. Oh, here our previous element is less than our current. So we're not moving backward. We're swapping positions of those two elements. And so on and so on. So, is it clear? Pretty simple algorithm, very similar with bubble sort. And who can tell me what's the big O or the worst scenario of this algorithm? Yeah. It's an array list, yeah, not linked list. Maria already said it's O and O n square. Because you can see on the animation, very cool animation, that basically it would be a loop inside the loop. Because we are moving, we are traversing the list, and we're doing like the loop operation backwards, like in the direction of the start of the list. So the worst scenario is the O(n) square. But what's the best scenario? Time complexity for the best scenario.
Zero operations, everything already sorted.
Yeah, but we. Yeah, but how you will know that it's already sorted? You need to do.
O of n, you have to loop through every element
Yeah.
once to check if it's bigger.
Yeah. Thank you, Hat.
You're welcome.
Yeah. So, and let's do revision here. What's the time complexity of bubble sort? The worst scenario and the best scenario?
It's n square.
Hmm?
N square is the worst
Mhm.
scenario and n is the best.
Yeah, yeah. Okay, so like they pretty similar, like in terms of integration, understanding, and time complexity. Let's move on. Selection sort. So this sort is pretty basic too. How does it work? When we start our algorithm, we are choosing our current element. Right now is 5. And we're starting to search for the lowest, for the like minimum element in the rest of the list. Like we're moving here, 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 here. We're moving like here. And our minimum element right now is 2. Then we're moving here. Our minimum element is 1. Moving here, our minimum element right now is 0. So we're storing index of this element. Like our minimum element index right now is 3. We're moving here, and our minimum element of this part of the list, what? What?
No, this index 3.
Yeah. So in the end of this iteration, we just swapping our current element and our lowest element. We just swapping them, and after first operation, we have something like this. And then we say that this part of the list already sorted, because it's the lowest element in all array. So next, our current element now is 2. And we're doing same thing. We're moving, and we're trying to find the minimum element of like this part of the list. And what it would be? Yeah, so now we're saying that our minimum index of minimum element is 2. And we are switching those 2 elements. Something like this. And we are saying that now this part of an array is sorted, and this part unsorted, and our next current element will be this one. Is it clear?
No.
what time complexity complexity
O of n squared,
N squared.
the worst case.
yeah, and the best case?
O of n. The same. I guess it's just the opposite to the insertion sort.
What?
Like as the opposite, I mean it sorts the left side. It goes in another side, like if you compare the animations.
I don't understand what
The
do you mean?
iterations in selection sort go to the right, while in
Yeah.
insertion sort they go to the left, like that.
Yeah, okay, but what's the best time complexity in the best scenario? Best scenario is when our list is already sorted, right?
O of n.
I think no. Maybe.
Like if it's already sorted, you have to iterate over each element once. So
Yeah.
n lengths of the array.
Yeah, but if your array is sorted, you like taking the first element and then you're trying to find minimum element, but you after you traverse all the array, you like, oh, my current element is the minimum element. Then you move here and saying, okay, this is my current element.
It doesn't check it really. So
Yeah. Yeah,
it's bigger than O of n.
yeah,
So it still stays on n squared.
yeah. So strange algorithm, right? Why do we need them? This I don't know, but it's very
Simple and efficient n squared.
yeah, but very very useful for your brains to train it, right? But all of those algorithms for children, because O n square is the bad time complexity, like not the worst, but pretty bad. So now we're going to talk about merge sort. So this is interesting because here we use recursion. So, for example, we have an array with 8 elements. What we do? It's pretty similar to the binary search. This algorithm uses some principles from there, and it's working in recursion. When we start this algorithm, what we do? We separating our list for 2 parts. And now we have 2 separate arrays. Then it's recursion. We continue, and now we're separating those 2. And now we have 4 arrays, every with 2 elements. And one more time. Now we have 8 arrays with and every of these arrays contain only 1 element. So the principle of this algorithm called divide and conquer. So this operation is about dividing. What we are doing is dividing this array to the lowest like possible amount of elements. And next operation is merge. We need to merge those elements. And it's pretty easy to have, for example, two sorted arrays and merge them into one sorted array, right? Because it's like shuffling cards. Like you can, if you have two hands of cards, like in one hand you have 6, 7, 9, 10. In another you have like 5, 7, 8. You just can take one card and put it, well, okay, bad analogy. Let's talk about what we have on the board. So when we have when we had such operation, dividing those elements, this our initial array into 8 arrays with only one element, we can merge starting from the bottom. So, for example, here we will merge two arrays at a time. Now we have two arrays, array with element 2 and array with one element 5. We're saying, okay, if first element of first array is lower than first element of second array, then I need to swap them. So we like recreating this bigger array with those smaller ones. So now we're checking, okay, this element is lower, so I will write it here, and this element is bigger, I will write it there, okay? The same operation here, we're checking, okay, if it's lower, then we're not like swapping, we writing in the same order. Same here. And same here. Now, we have two arrays. Every of those arrays have two elements. And we have our array with 4 elements that we need to fill with elements from those two arrays. And now we are doing the merge. We're checking first elements. Okay, 2 is bigger than 0. So the first element will be 0. Then we already put 0 in here, so we move in here. And we're checking. 2 is less than 7. So we will write 2 here and move here. Okay, 5 is less than 7. So writing 5. And we left with 7. We need to write 7. Is it clear? This is called the merge operation. Do you have any questions? It may be pretty confusing, so we can exercise on this part. So I need your help with this. So, Denis, for example, what's the first operation of merge of those two arrays into this one?
We try to solve which number is more. For example, here we between 1 and 3.
Yeah.
3 is bigger than 1, so it means 1 is less than 3, so 1 will be over first.
Mm-hmm. Okay.
Then we compare. Then we took. Do we need to compare 3 with 9?
Yeah. Mhm.
3 is less than 9, so that's why we write it here.
Yeah.
And then compare 9 with 4.
Mm-hmm.
Because it is like the second in the second number in the first no partial option no
Mm-hmm. Yeah.
so and 4 with 9 yeah
Okay. So now we have two already sorted lists, and we need to do the same operation for those two arrays to fill our original array. But like this is just a test scenario. We can have like array with million elements, and we just will have more those divisions, right? So who want to help me? Bogdan. So what we need to do? What our first operation in here?
To compare 0 with 1,
Yeah.
so the 0 is less than 1,
Mm-hmm.
here writing to 0,
Yeah. So this is first operation. What next?
compare 2
Mm-hmm.
with 1,
Mm-hmm.
and the 1 is less, so
Yeah.
after that compare 5 with 3,
Uh,
or 3 with 5.
you forgot.
Oh,
Two.
because it is sorry.
Uh-huh.
Compare 2 with 3,
Mm-hmm.
the 2 is less.
Mm-hmm.
After that we are comparing our 5 with 3,
Yeah.
the 3 is less.
Mm-hmm.
3. Compare 5 with 4, or yes, the 4 is less.
Mm-hmm.
This. Oh, the mic is off. After that, we are comparing 5 with 7, or no? We can do it,
Why? Why we need this?
because after the
So you already compared elements from this and this one, and why do you need to compare 5 and 7?
because the 5 is less than 7.
Yeah, but those elements.
But we already have.
Yeah.
So we're writing 5 and comparing 8 with 7. Oh, 9 is.
But you forgot about 5. What we are doing with 5?
Comparing the 5 with 9,
Yeah.
the 5 is less than 9.
Mm-hmm.
And after that, we are comparing 7.
Yeah. And now we have a sorted list. Thank you for your help. So, do you have questions about this algorithm? Like, not so hard.
I have a question.
Yeah.
Can you hear me?
Yeah.
That's great. I think I have missed the part where you explained why we need to compare, like, how do we compare the little arrays between each other? Could you please
Yeah.
say it again? Because I have missed, I didn't hear guys talking, so
Uh-huh.
like,
Yeah. Okay.
that'd be great.
Let's introduce kind of pointer for each
Yeah.
part so it will
Yeah.
be more understandable.
Yeah. So now let's imagine that we have some sort of pointer for every of those arrays, and we have, for example, variable I equal 0. It's like our current element of this array and current element of this array. So first of all, we are comparing two current elements. It's 0 and 1. 0 is less. 0 goes in our like upper array, like array that will have the merge the two of those arrays merged in one, right?
Yeah, okay.
Yeah, and when we move an element from this array, we updating our current element. And now our current element is in first array is 2, and our current element in the second array is still the like element with, yeah. So now we're comparing those two. One less, we're moving it here, and now we're updating this one. So now our current element here is 3, and so on and so forth.
Okay.
Yeah. Do you have another question, maybe? Okay. I have a like example from the real life where you may need such knowledge. So sometime ago I find such images, pretty cool effects, and I was interested how to recreate it. And this effect called pixel sorting. So what's the point? As you know, every image on your screen contain every picture on your screen is basically built from pixels, right? And pixel is some unit that have 3 LEDs, red, green, and blue. So every image that you can see is a matrix of those pixels, like two-dimensional matrix, like two-dimensional array, right? So, and every pixel have different values. For example, the amount of red, green, blue, the brightness, and we can sort those pixels in the image by some field. For example, brightness. So here you can see that in this image, for example, we can see that those lines looks like some gradients because those pixels sorted by brightness. So it starts from the bright one and ends with the dark one. So when I tried to recreate this effect, I was lazy and I used a bubble sort. And I had an image with such resolution. And in such example, we know that time complexity of bubble sort is O n square. So I had such amount of pixels and square, and plus I needed to multiply it on the height of the image. And I remember that every processing of every image were like nightmare. It's like 1 plus minute for every image. And then I searched for another algorithms, and I find merge sort. So with merge sort, it's like 5 seconds. So what time complexity of merge sort? What do you think? Yeah.
Sorry, so what is pixel sorting? Did you just take a normal picture
Yeah.
and sort each
Yeah.
line vertical?
Yeah.
By what?
Yeah. So
By their own ID.
no, like by brightness, for example. So every pixel is have some color, and every color have brightness. So you just programmatically you have an access for every pixel, and like one row of pixels, it's like an array of object pixel, and object pixel have fields like red, green, blue, brightness, like I don't know, something, and you can like in your arrays in test cases you can swap those pixels, and in the end you will have updated image with some effect. It's very interesting. You can try it yourself. You already have knowledge to do this. Like you can ask me some directions when we will end our class. But it's pretty easy, and it's when when you doing some test assignment, it's not so interesting because you don't have like purpose. And here you have results, you have purpose, and it's very funny to see your knowledge in action. So in every language. I wrote this in Dart and in C++. So the same algorithm. So it doesn't matter the language, it's just algorithms.
You can even write it on Brainform if you want.
Yeah. So what the time complexity of merge sort? What do you think? Yeah.
N times logarithm of n.
Yeah. Amazing. Why? And you need the mic.
Is it working? Okay, it's working. So basically, each merge operation is n. Each time complexity is n
Mhm.
because we are traversing one array and comparing with another. So it's n operations, and we need to do log n of this merging operation
Mhm.
because we have like if we have array 8, so we have 3 merging
Mhm.
operations because we divide it with 3 times
Mhm.
as in boundary as in binary search.
Yeah. 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 So you're right. It's from the binary search where the time complexity is log n. It's pretty similar because you, like in binary search, you're dividing like binary. So yeah.
Well, to jump in, I really like this visualization, and so well done with actually formula. What I like in this image, this kind of image, that you could quite maybe not mathematical, because this is you mathematically could come to this conclusion, but visually we could simplify all of that in very easy way. So tell me please, how much iterations, so how much, not iterations, how much comparison or something, key operations we should do on this side? 8, more basically n, size. And we should do this n size iterations how much times? So this is it. Basically, even we could call it, but this is just not matter for big O. We could just call it log n, and it's not so important. But you understand why it is log n? So we could count basically, yeah? 1, 2, 3. So when we divide this array, so 2 power of 3, we get 8. Is it correct? So that's why we have this. So how to know this 1, 2, 3? This is just formula mathematical. So that's why just multiply this on that and you get a big O. So it is maybe more simplified way. So more mathematical, you could use formulas, but every time you have this division by 2, you know that, oh, it is log n. So that's why it's quite, so you could visualize that. Yeah, sorry.
Yeah, I have.
Oh, you have.
Yeah. I'm done, really. Maybe you have some questions about merge sort.
Number of loops is
What?
number of loops in the merge sort.
What do you mean by loops?
First we need traverse,
Yeah.
and then we need to have how much more?
So basically, we are not doing the traversing. We dividing, dividing, dividing,
Okay.
and then merging. Yeah.
So we recursively divide and then one loop for
Yeah, basically we dividing, and in the end of those recursion of division of dividing, we have method merge that accepts two arrays, and we don't know the size of an array. We just we can merge every array, like if it's have only one element or if it have 500 elements, we will merge them into the bigger array, like twice bigger. So yeah. So yeah, thank you. And for assignment in the class, we want you to do your favorite task in the world, to do to do trace for all those sorts using this test array that you can see on the screen. So thank you.